Hello everyone. This problem is called make a large island. So let's see the problem statement. It says that you are given n cross n binary matrix. So by binary matrix we mean it has either 0 or 1 and it's a square, but the same problem can be extended for different rows and columns in the grid. So you are allowed to change at most 1 0 to 1. So either you convert 1 0 to 1 or you don't convert. You cannot convert more than 1 0. So then we have to return the size of largest island in the grid after applying this operation. So either this operation is applied or not. So after that, so island is 4 directionally connected. So if we have a grid like this and we are looking at this land, so let's say here the value is 1. So 1 denotes land, 0 denotes water. So all the ones that are connected form one island, and there are some other ones. This is another island and some other one, and then the rest are zeros or water, and everything outside the grid is water, or you can think of at 0. So only 4 direction: up, down, left, right. For example, if we have this example 1 0 0 1. So in this case we have 2 islands. So these two are not connected because we are allowed only in 4 directions. So in this case we have 2 islands and of size 1 and 1. By size we mean number of ones in this island. So maximum is 1. But if we convert one of the zeros to 1, we are allowed to do that. So let's say we convert this to 1. So now this 1 is connected to this one because it's on the right, and this is also connected. So we get one big island of size 3. So in this case the answer is 3. But let's say we have 1 1 1 1. In this case all are already 1, so we cannot convert any 0 to 1. So in this case it's already 4, and this is the largest possible size. So how we can solve that? So let's see. So let's say we have, let's take one example first. Let's say we have 1 1 0 0 0 1 1 1 0 1 0 0. So in this case we have one island of size 2. Then again here we have 3 and 1. So 2 3 1. Maximum is 3. Now if we convert this 0 to 1, this will be part of this island. So size will be 4, and that will be maximum. But this is not the optimal, because if you, instead of that, if you convert this 0 to 1, now these all are connected. So you get 2 3 and 3 more 6. Now let's say we don't convert this, but instead we convert this middle one. Now these two are connected, and this is also part of that. These two are also part of that, and in fact this one is also part of that. So all the 7 ones are connected, so we get 7. So you see there are multiple zeros you can convert, but which one gives the maximum result? So in this case we will return 7 by converting this 0 to 1. So what will be the general approach? So first thing is that you have to traverse this grid. So let's say we have some generic grid. So first we will do, let's say, DFS, and when a DFS terminates, we visit all the land in a given island, but there are some more disconnected ones. So we do again DFS. So we will do DFS as many times as there are number of islands. So if there are 3 disconnected islands, we will do DFS 3 times. And the way to do is that we start from top, go right. First one we encounter, first cell, first one that is not visited, we start DFS there. So it will visit all the connected ones. Again continue, keep next row. We again found 1 and 1 which is not visited. So we start DFS. So in this fashion we will do DFS and visit all the lands. And while traversing, we can keep track of what is the area, how many cells are connected. So we come to this one. Let's take this example in only 1 1 0 0 0 0 1 1 0 1 0 1. So it's not n cross n. I am taking general m cross n. So we start BFS here. So we see it's 1. We can only go to 1, not 0, because 0 is water. Then we can come here. So we traverse this also. Now top, left, bottom, down, we cannot go anywhere. So in this case, we got some island. Let's call it island. We will give some index. So we already have 0 and 1 values, so we can give it an index of 2. So 2 will in fact also work as visited. So whenever you visit, let's say current island index is 2. We will start with 2 because 0 and 1 is taken. And we keep on making them 2 wherever we visit. So from 2 we will see that right is 0, cannot go. Bottom is 0, cannot go. Top, out of bounds, we will not go. Left is 2. 2 means visited. Anything other than 1 is visited. So we will stop. So for island 2, we have an area of 2. Whenever we go to a cell, unvisited cell, we increment the count. So our DFS call can return additionally the area of that island. Now we will come here 0, 0, 0, 0, 1. So whenever we find 1, we start DFS. Now we start DFS. And now this is a separate DFS call. So we can have some identifier for island 3. So we make it 3. Right we can go, it's 1. So make it 3. Now counter is 2. Then bottom we can go. Again make it 3. Now counter is 3. Now we cannot go anywhere. So for island 3, area is 3. And again we find another one. So we start DFS here and make it 4. So for island 4, the area is just 1. So we have 3 islands and their areas are 2, 3 and 1. So far we have found an island of area 3. But we are allowed to convert one of the zeros to 1. Let's say islands are far apart. So one island is here, there are a bulk of zeros here, then there is one island here and there is one island here. So no matter what zero we convert to 1, we are not going to connect any of the 2 islands. But we will, in that case, we will pick whichever is the largest island and whichever is the nearest 0, convert that to 1. So we will get max area plus 1 in that case, plus 1. So this is the minimum we can get. So here if we have found an island of 3, we can get at least 4 because one of the zeros we will convert. But our goal should be how we can maximize it. So there are many zeros, so which one we will pick. So in this case we tried this one, then this one. So this central one gave the maximum best result of 7. So what we will do here, we will go to all the zeros. Now we will not need to do any traversal. We have already traversed this grid once and that's enough. Now we will see all the zeros one by one and see what are the neighboring islands. So we also have the island index. So this is island ID and this is area. You can store it in a map, hash map. So our goal should be that whenever we meet a zero, a candidate 0. So we will think whether this 0 is a candidate or not. So this is 0. So what is the best thing that can happen by converting this 0 to 1? So that it connects multiple islands. So let's say there was some island X here on the left. And of course it has some other values. So it has area some, let's say A of X. Or to simplify, let's say this has an area of 10. So 10 pixels are connected, including this X. And this X is one of these IDs, island ID. In the top, we have another island, let's say Y. And it further has some area, let's say 8. In the bottom, let's say it's 0. In the right, we have, let's say Z. And it has also some area, let's say 5. So here the maximum was, let's say 10. So we had an answer of 10. Now if we convert this 0 to 1, what will happen? This x is connected to this one and this one is connected to this y. So these cells are 1 because this is part of an island. So all three will get connected and we will get 10 plus 8 plus 5. So now these are one single island. 10 plus 8 plus 5 and one additional this 0 which was converted to 1. So we got 18, 24. So now we have got an area of single island of size 24. Earlier we had just 10 here. So what is the approach here? So we have some max area while doing DFS itself. So in this case it was 3. Now what we will do, we will go to all the cells in the grid which are 0 and look at all the 4 neighbors and see what is their area. So summation of areas of a given 0. So we are at this cell 0. It's 0. We are here. We are looking at its neighbor 1, 2, 3 and 4. Each of them may have some area. Even this one will have some area. It's 0. So we add all of these 4. If it's 0, and how do we get the area? We just need to see the neighbor and not do DFS because we already have the islands. And these cells will have these values, updated values, 2, 3, 4, 5 and so on, starting from 2. So we see top, if it's 0, ignore it. If it, let's say any number greater than 1, let's say it's 2, we see what is the area of 2, we come to this table, it's 2. So we have 2 plus next 4. Is there 4 here? Yes. Its area is 1. So 1. Then here we have 3. Its area is 3. And then we have 1. 1 will not be there. 1 is unvisited. So in this case it's 6 and 1 this 0 itself. So we will always add 1. So 7. So max area equal to maximum of max area and this new area. Let's call it new area. And this will be done for all the zeros. We will see for all the zeros. So it will be one more traversal of the grid. So first traversal for all the islands and next one traversal for all the zeros, just looking at neighbors. And this new area. And keep on updating this area for all the zeros and ultimately we will return this. But there is one more thing you need to do. So when you are at this 0, let's say, and there is some island not equal to 0. So let's say this is 0, this is 0, but this is not 0. So you will not blindly pick that. Let's say its ID is 3. And here also it's 3. It can be 3 because maybe it's connected in this fashion. Somehow. So here it's 0. Let's think of one scenario. So here it's 1, here it's 1, here it's 1, here it's 0, here it's 0, 1, 0, 1, 1, 1. So you see that these are connected. In fact, this everything is connected, part of the same island. So it's not necessary that if we are looking at this 0, its left neighbor and right neighbor will be part of different islands. It can be part of same island. So here we will not blindly add all the values. We can. So if we pick 2, if one of the neighbors is 2, so we insert it in a set 2. Next, let's say here also it's 2, non-zero. So we will not blindly get the value of island 2 and add here, but we will check whether it's already included or not. So it's already included, so leave it. So I think this completes the solution. So what will be the time complexity? So if there are m cross n cells, then it's of the order of n cross n. So first time we traverse all the islands, and then next time we just look for all the zeros and look at its 4 neighbors for each 0. So 4 times number of zeros. So again, in the worst case, m cross n. So this is the time complexity. And space, actually we will be modifying this original grid itself. So we will not be using any extra space. we can think of as O of 1. Now let's code this approach. So here it's mentioned n cross n, but let's make it more generic. Let's call it m cross n. It will solve some generic case. It's not necessary an square grid. So grid dot size. It's also given that it's not empty, but let's add that base case check also. That will complete our solution. So if m is equal to 0, then it's empty, so return 0. The area maximum size of island will be 0. Then n is the number of columns, so take the first row and number of elements in it. Then let's take some island index, so let's call it idx equal to 2. So 0 and 1 are already taken. Then we will have a hash map where we will store island index and its corresponding area. So this will come from the DFS of all the islands. Now, so initially max area is 0, and what we will do for so this is the standard DFS, the way we do it. So if grid I j is equal to 1, we are not interested in zeros, we cannot go there. If it's 1, then it's unvisited, because when we visit we change its value to some island index, denoting it's part of island number 3, island number 4, and so on. So let's say our DFS call, which we will define shortly, return some area, how many cells it visited. So we have DFS, and then we pass the grid and also the position, injth cell, and we will also pass the island index. So this is island index. Then whatever area it returned, we will check if it's more than max area or not. If it's less, we are not interested. So max of max area and area. So we are keeping track of running max area. Then we will insert this into this hash map. So islands, and the island index is for this DFS is idx equal to the returned area, and for the next DFS, when next DFS is called, we will pass a new index. So increment the index. So now first let's define the DFS itself, then we will process further. So int DFS, and here we will pass this grid, and second is position, so we will call it, let's say, row and column, and then index. So if grid RC not equal to 1, then return 0. So this is base case, like if it's already visited or it's water, and somehow we call DFS on that, then simply return 0. Some base case. M is grid dot size, N is grid 0 dot size. So we are already checking it in the main function that it's not empty, so there is no harm in doing grid 0 here, it will not fail. Then count is the running count of cells visited, which will denote area. So grid RC, now we are sure that it's 1, so we will assign it the current island index, and we increment the count. So whenever we visit a cell, we increment the count or the area. We can call it area also. So now let's look at all the 4 neighbors. So if r plus 1, that is we are going down one row. So if it should be less than m. Maximum value of r should be m minus 1. So if it's within bounds, we will do DFS here. So count plus equal to DFS. Again grid. Again r plus 1 is the new row. It's the bottom neighbor. Same column and same island. So you see here we are not checking whether it's 1 or not. So that check will be performed here. You can also add that check here. It's up to you. So this makes it simpler. Instead of adding checks multiple times, we have just one base check here. So let's do it for all the 4 neighbors. So next will be c plus 1. C plus 1 should be less than n, and then c plus 1, it's the right neighbor. Then next will be r minus 1, top neighbor, and it should be more than or equal to 0. It can be 0 as well. R minus 1, then C minus 1, and finally return count. So now our DFS is implemented. Now we have this map where we have island index and corresponding area. Now we will go to all the zeros and look at neighboring islands and their areas. So again this loop. So we are visiting the grid twice. If grid I j is equal to 0, so we talked about that we should only include an island's area once, because it may be the case that 2 of the neighbors are part of same island. So we have some set here where we keep island index. You can think of it as anything, let's call it neighbors, and if again the same checks that we did here, boundary checks. So if I minus 1 is greater than equal to 0 and grid I minus 1 j it's not equal to 0, then neighbors dot insert I minus 1. So we are just inserting unique neighbors, and then finally we will add their areas. So that is one way. Yeah, and the same thing we will do for all the 4. So j minus 1 then I plus 1, it should be less than m, and j plus 1 should be less than n. And so we have all the neighbors, all the unique neighbors. So for int nn in neighbors, what we can do, so let's keep one current area here. One, because we are converting the current cell's 0 value to 1, so we already have an area of 1, and now we are looking at all the neighbors. So current area plus equal to islands. So this is the hash map where we are storing island index and the corresponding area, and then again compare max area equal to max of max area and current area, and finally we can return the max area. I think this should work. Let's see if there are any issues here. So yeah, it passes these test cases. Now let's submit, and it's accepted. So this was very simple. It looked tough, but if you break it into smaller tasks, you can solve it easily. So see you in the next video.